So just for a moment, if I might, before introducing our speaker, I'd like to touch on the basis for this award. This award is really a reflection of Donald Sussman's 30-year career in alternative investments and fund management, focusing on both quantitative and fundamental strategies. Donald Sussman is the founder of Trust Asset Management, Paloma Funds, and New China Capital Management, LLC. Don was the recipient of Institutional Investors' Alternative Investment News Lifetime Achievement Award in 2004. And this Sussman Award is given to the individual or group who best exemplify Donald's impressive career as a successful investor in quantitative investment strategies and models. Throughout the year of the award, our honoree will join us for lectures illuminating this important area of the understandings of investing. This year, which as I said is the inaugural year for this prize, MIT Sloan is happy to bestow this honor of the S. Donald Sussman Award to Dr. Robert Litterman. You can sit. Dr. Litterman is currently the chairman of the Risk Committee at Capos Capital, recently retired from a 23-year career at Goldman Sachs, where he was named partner in 1994 and oversaw the Quantitative Investment Strategies Group and Global Investment Strategies. In an earlier role at Goldman, Dr. Litterman was the co-head of fixed income research and model development, along with our own Fisher Black. During his career, Dr. Litterman has published a number of groundbreaking studies in the areas of asset allocation and risk management, and is the co-developer with Fisher Black of the Black-Litterman Global Asset Model, which is one of the most fundamental papers related to investment management. Would you please, you have a PhD in economics from the University of Minnesota, bachelor's degree from Stanford University, and we're so proud to welcome you to MIT Sloan. Please welcome Dr. Litterman.
Thank you. Well, thank you so much. It's a pleasure to be here. I really want to thank MIT Sloan and Donald Sussman for this great honor, honoring, quote, a successful investor in quantitative investment strategies and models. You know, quantitative investors focus their attention on finding and taking advantage of risk premiums that are not priced appropriately. And my topic this afternoon is the economics of risk pricing. But I've chosen to focus on a particular risk, climate risk, which is an important, urgent, and very timely example in which to consider the implications of appropriate risk pricing. Climate risk is timely because we've all suffered through an unusually warm and dry summer. Climate risk is urgent because climate risk is not being priced appropriately. It's not being priced rationally by society, and that mistake wastefully creates unnecessary costs and risks for generations to come. And climate risk is important because it's a chemistry experiment being performed on the planet Earth with consequences of unknown magnitude. Now, most people have difficulty rationally confronting the possibility of catastrophic events that may occur with small probabilities in the distant future. Where does climate risk rank, for example, relative to nuclear war, a global pandemic, or an asteroid hitting the Earth? I don't know whether these other risks are being priced appropriately, but what is special about climate risk is that we can all publicly observe the risk premium that is being applied by governments around the world, and that risk premium is tragically incorrect. Greenhouse gases are currently being subsidized by governments. Those emissions should immediately be priced appropriately everywhere. Any economic activity anywhere on the globe that creates significant greenhouse gases should be required to reflect the impact of those emissions in the price of its products. There should be strict liability for any government or elected official that opposes this policy. The only interesting question is, what is the right price? And that's my topic today. We're all filling up a common reservoir, the Earth's atmosphere. That's the picture that you should have in your mind as you think about climate risk. The remaining capacity of that atmosphere to absorb emissions safely is unknown, but make no mistake, it's limited. That unknown remaining capacity is a scarce resource. People living today, acting behalf not only of themselves, but all future generations, need to decide how much to charge each other for using up this scarce resource. Because of the uncertainty of outcomes associated with filling up the reservoir, the appropriate price depends critically on societal risk aversion. Any underpricing early on will inevitably be compensated through overpricing relative to the optimal price path later on. If the reservoir overflows, a catastrophe could ensue. Climate risk is indeed an urgent risk management problem. At the 2010 climate conference in Cancun, Mexico, Felipe Calderon, the president, told the attendees, it's time to slam on the brake. He was correct. The brake is the price of emissions. But to this day, governments are not pricing climate risk appropriately, and elected officials should be held strictly accountable for this failure. If something down the road goes horribly wrong, today's mispricing of risk by governments will have been responsible. I'm not, however, trying to alarm you. We understand the problem, and we know how to solve it. The risk management problem itself is very straightforward to understand. Globally, governments are subsidizing the creation of climate risk. Not pricing risk appropriately creates incentives for both individuals and businesses to take too much risk. The actions that are thereby induced increase the likelihood of a future disaster. We also know how to solve this problem. What governments need to do immediately is to price climate risk appropriately. That's all. The solution is that simple. The basic policy required to address climate risk does not require government expenditures. It does not require government subsidies of new technologies or new infrastructure. Although those may be justified, they're not the main issue. Solving the climate problem change does not require government regulation of society. Such actions are not central to government's response. Here's the bottom line. The actions that society needs to take to solve the climate risk problem will occur naturally on their own if and only if emissions are priced appropriately. No one can predict all of the impacts of pricing emissions, and no one knows in advance what technologies, enterprises, and behaviors pricing will induce. What we can guess, no one can guess what the solutions will be. No one knows how people will react, but what we can do is to trust the price mechanism to work. Incentives affect behavior. Because the atmosphere is commonly owned, governments are needed to create the correct incentives. Governments globally need to institute an appropriate price on emissions and otherwise basically get out of the way. The solution is simple, obvious, and extremely urgent. We are all very familiar with the political frictions that prevent global action. But despite these frictions, I think climate risk will be priced surprisingly soon in all significant markets around the world. And I'm not alone. Many companies, including, for example, even ExxonMobil, have made a complete about-face on this issue. Exxon, for example, has enunciated a policy toward climate change that starts with the principle that any price of emissions should be based on science and economics. And they are exactly correct on this principle. And they're building into their business plan the assumption that one way or another, in 3 years, emissions will be priced at $20 per ton of carbon dioxide in the United States, and that by 2030, this will have risen to about $60 per ton. I think they're also correct that emissions will be priced at a significant level in 3 years in the United States. However, as you will see, I wouldn't bet on their forecast of the path for future emissions prices. As I will explain, the economics of pricing climate risk imply that the price shouldn't be expected to go up that quickly over time, nor necessarily that high. Nonetheless, as we watch this pricing process develop too slowly over time, there are unanswered questions, and I think there are at least two important components that still require significant input from academia. First, we need better models of the appropriate price for emissions, models based on science and economics that, among other improvements, appropriately incorporate uncertainties uncertainties about catastrophic risk, and uncertainties about mitigation and adaptation. And most important, we need models that appropriately incorporate risk aversion. Second, we need to design a governance structure to set the global price for emissions in a way that is based on science and economics and is as independent of governments as possible, independent of the political process and corporate and private influences. My prediction is this: pricing of emissions will be instituted surprisingly quickly, and when instituted will work surprisingly well. We can solve this problem if we move quickly and appropriately. Even though most people will certainly not even know or recognize that it is happening, when emissions are priced appropriately, there will be an invisible, instantaneous change in human behavior. That's the amazing part about the pricing process. The impact of appropriate pricing of emissions at the wholesale level will have a modest impact on consumer behavior at the retail level. It is estimated, for example, that an appropriate emissions tax will add about $20 per passenger on a flight from the US to Europe. But the impact of emissions themselves, the impact on emissions themselves in the long run will be enormous. And the process is flexible and self-correcting. The price will fluctuate over time to recognize whatever is happening, whether it's good news or bad news at that time. In contrast, the current approach by governments around the world starts with incentives that go the wrong way. Government subsidies are motivating firms to produce energy from fossil fuels and motivating people to consume fossil fuels. Human society has not slammed on the brake. It's not braking at all. The government foot is still pressing hard on the fossil fuel accelerator. And then the same governments try to fix the climate problem that they continue to incent by relying on more regulation and more government subsidies. It is such a colossal waste of money. Incent the pollution and then subsidize and regulate people to try and clean it up. This approach to climate risk is not rational policy. It is dangerous, it is a tremendous waste of resources, and it will never work. Only some sort of societal irrationality explains not using the price system to allocate efficiently over time the Earth's remaining capacity to safely absorb emissions. Now, risk management became my specialty when I was a partner at Goldman Sachs. I sat on the firm's risk committee as the first waves of the mortgage meltdown crashed ashore. The fundamental risk management error that led to the financial meltdown, the recession, and all this misery was a mispricing of systematic risk embedded in mortgages. To me, the lesson of the financial crisis was very simple. Incentives affect behavior. There was a particular large systematic economic risk embedded in mortgages that wasn't recognized and therefore wasn't priced. The systematic component of mortgage risk was missed until it was too late. That systematic risk was the risk of what happened, the risk that mortgages defaulting would cause the economy to slow down, increasing defaults, leading to positive feedback that would cause the financial system, holding a huge stock of mortgages, to melt down. That risk wasn't recognized ahead of time, and therefore that risk wasn't priced into mortgages. Not pricing this systematic risk into mortgages appropriately led to too much mortgage risk being created. The value of the stock of mortgages with unappreciated risk sitting on the balance sheets melted down as the risk was recognized, and that meltdown caused the disaster. Incorrect incentives caused by mispricing risk led to the actions which created the conditions that led to the financial crisis. Climate risk is exactly the same story. Stocks of emissions, rather than mortgages, are piling up, potentially creating a disaster. It's a well-known story, tragically playing out in front of our eyes. That prices matter was an insight that I first took to heart as an undergraduate at Stanford University in 1970, when Stanford introduced an interdisciplinary program in human biology, and I dropped out of physics and joined its inaugural class. I like the idea of recognizing right from the outset that people are animals, part of nature. I enjoyed studying them in this light. Animals respond to incentives. It seemed pretty obvious to me that if you want to understand human behavior, you have to understand that people also respond to incentives. Prices matter. People may not be perfectly rational, but in the long run, they do respond to incentives. That led me to want to study economics, and I was lucky enough to find myself in graduate school studying economics at the University of Minnesota in the late 1970s at a very exciting time. My two advisors at Minnesota Tom Sargent and Chris Sims, just last year deservedly won the Nobel Prize in Economics for their work in understanding and testing the implications of rational expectations. That background led me to 2 years of teaching economics here at MIT, 5 years of research in macroeconomics and finance at the Federal Reserve Bank of Minneapolis, and then on to a career on Wall Street. Along the way, I was trained in risk management by some of the best minds in the Federal Reserve System in the 1980s, and later in financial markets at Goldman Sachs in the 1990s. I had 2 very important mentors. My mentor in pricing risk was Fisher Black, a genius who I was lucky enough to work with at MIT and later at Goldman Sachs. In 1994, after a period in which Goldman suffered significant bond trading losses, I was made a partner and asked to head a new department, firm-wide risk management. My mentor in risk management at Goldman Sachs was Jerry Corrigan, a protege of Paul Volcker. I worked for Jerry first as an economist when he was president of the Minneapolis Fed, and later as his partner in Goldman Sachs, where he had become chairman of its risk committee. I learned something very interesting about risk management from Jerry that I'd like to share with you. You might think the responsibility of the risk manager is to manage risk. It certainly sounds that way, doesn't it? But the job of the risk manager is not to manage risk. The job of the risk manager is to measure risk, to understand risk, to monitor risk, and especially to report the right information about risk to the right people at the right time. Information that is accurate, comprehensible, and actionable. What is hidden in that lengthy description is that the risk manager has a very important and delicate responsibility to decide who needs to know what and when about the risks that they face. That responsibility also requires a risk manager to become an expert in pricing risk and to be able to recognize when risk is being sized appropriately by an organization and when it is not. The risk manager must be able to escalate those observations to appropriate management and, if necessary, to escalate those observations all the way up the chain of command until the risk is appropriately addressed or until he or she is fired, which happens sometimes. The job of the risk manager is absolutely essential to an organization for the reasons that we've already highlighted. When a risk is not priced, appreciated, or understood, or the hurdle for taking risk is too low, an organization will be led to take too much risk, and that can lead to disaster. Climate risk has not been priced at all until recently in a few places. At the same time, fossil fuel consumption has been heavily subsidized. Historically and today, net-net, governments are strongly subsidizing the creation of emissions. Given that incentive, climate risk has wastefully and dangerously grown in size. Many governments, including those in Europe, South Korea, Australia, some provinces in Canada, the state of California, have started to try to price climate risk, though most often inefficiently and at very low levels with significant political opposition. Other efforts are starting now, for instance, in China and India. And although those efforts show leadership, without a coordinated global effort, such efforts cannot solve the problem. And incredibly, the governments of many of the largest emitting countries, including the United States, have not yet joined the global effort to price emissions. In the case of the United States, the government has recently officially recognized that for regulatory purposes, the appropriate credit for emissions reduction is around $20 per ton of carbon dioxide. However, by some irrational convolution of logic, the same United States government fails to recognize that if $20 is the appropriate credit for reducing emissions, then $20 is also the appropriate tax for those creating those same carbon dioxide emissions. And although it now recognizes the cost of the emissions in the regulatory policy, through tax policy, the U.S. government continues to incentivize our economy to fill the atmosphere with emissions. Regulatory policy is being used to try and clean up the mess that the government itself is creating. A safe atmosphere is a resource critical to a healthy environment and to the well-being of those who are not yet born. All governments, including that of the United States, know that emissions will have to be priced soon. But the current U.S. policy of postponing that eventuality increases the risk and pushes increased costs into the future. One of the important lessons that I learned in the economics department at Minnesota is the following. It never makes sense for a government to smooth prices. Never. Prices don't enter utility functions. Allocations do. Herb Moehring, a brilliant transportation economist at Minnesota who just passed away this year, pounded that lesson into my brain at an impressionable age. If a government policy sets a price, in this case, the price of carbon emissions, and if the appropriate price is here, and the current price is somewhere else, such as down there, then the correct government policy is to get that price to the appropriate level immediately, not to move it there slowly over time. Some people will be hurt, no doubt, by changing the price. But if a certain price is the appropriate price after you take everyone's utility appropriately into account, then that's where it should be. The slow reaction that we are observing in the case of carbon emissions is a dangerous mistake. The appropriate price for emissions reflects the fact that emissions create an externality. The cost to society of emitting greenhouse gases is greater than the cost faced by the individual or business creating the emission. The appropriate government policy in this case is to price the externality in order to recognize the cost to society and to incent appropriate behavior. The fact that all emissions enter a common atmosphere means that the cost to society is the same regardless of where the emission is created. This fact leads to a very important implication. At any point in time, there's one and only one appropriate price for emissions, and it's the same in every country around the world. In order to understand what determines that appropriate price today, we need to focus on the distribution of the uncertain future damages created by emissions. Increasing emissions will impact the distribution of damages in two ways. First, there's the impact on the mean. Additional emissions increase the expected damage associated with climate change. I will focus, however, on the second impact, which is just as important, if not more so. The second impact is on the risk. Emissions increase the thickness of the lower tail, the risk of global catastrophic outcomes from climate change. Let's get started by considering a series of questions. We'll start with the easier questions first, and then move on to those that are more challenging and interesting. Is climate change real and caused by human actions? Well, of course it is. Unfortunately, the way this question is framed often has led scientists in defending the reality of climate change to play down their uncertainty about future impacts. Here's a much more interesting question that we should be asking. Is the uncertainty about the impact of humans increasing greenhouse gases in the atmosphere real? Oh yes, absolutely. We've never been down this road before. There's tremendous uncertainty about the long-term impact of changing the chemistry of the atmosphere. Here's another interesting question. Is a devastating natural disaster outside the realm of possibility? Sadly, the answer to this question is a resounding no. We have no idea what might happen as we dramatically heat up the Earth, acidify the oceans, and perform this unprecedented chemistry experiment on our planet. And here's an even more interesting question. Do we know when, where, or how a catastrophe, a catastrophic natural disaster caused by this experiment might happen? Again, the answer is no. We have no idea. That uncertainty is risk. So now, more than ever, we must reframe the climate debate around the principles of risk management. Think of the Earth's atmosphere as a reservoir for greenhouse gases. The level is measured in parts per million of carbon dioxide in the atmosphere. The historical level was 280 parts per million. Today it's 395. Currently, the level is rising at a rate of about 2.5 parts per million per year, faster than ever before in human history. Now think about this question. Does it matter how high we fill this reservoir? Yes, it does. The probability of a catastrophic impact rises with this level. And here's a tricky question. Should adding emissions to the atmosphere be priced appropriately? Does anyone think the answer is no? So what makes this question tricky? Well, it's because it's not even a question. Although it sounds like a question, it's actually a tautology. Everything should be priced appropriately. Such statements are true because of the meanings of the word should and appropriately. Why would it ever make sense to price emissions inappropriately? So the final, and by far the most interesting question, really the only interesting question, is this: what is the appropriate price for carbon emissions? Try to imagine the lower tail of the distribution of damages, in other words, the worst case scenarios. Try to think about a tipping point in global warming, a point where feedbacks become positive, where impacts become nonlinear, perhaps unimaginably so. The cause could be the release of methane from melting tundra, the release of hydrates from a warming ocean, or the burning of forests facing heat and drought, or some other danger that we have not yet recognized. It's painful to think about these scenarios, and it's very hard for scientists to estimate the probabilities of such events. Nonetheless, it is part of what risk management requires. Risk managers are trained to think carefully about painful scenarios, about what we call the lower tail of the distribution of outcomes. Clearly, the probability of such events rises as we fill the reservoir. There is tremendous uncertainty about what those probabilities are, but we do know that they are small as long as the reservoir is near historical levels, and that their probability rises as we increase the level of emissions in the atmosphere. I want you to think about that lower tail. What is the probability of a catastrophe at 400 parts per million? How much higher is it at 500 parts per million, or 600 parts per million, and so on? How big are these probabilities? How thick is this tail? No one knows. These small but growing probabilities, which represent catastrophic risk, are themselves highly uncertain. But economists nonetheless agree the appropriate price for climate risk depends in large part on the thickness of that tail. But before we discuss this question, I want to tell you a risk management story. There is a fascinating nugget of historical wisdom buried in this story. It's the legal concept of strict liability. Strict liability dates back to English common law, but in the United States, this concept is intertwined with this event. The idea of strict liability is very simple. Certain actions, like filling up a reservoir, are inherently dangerous. Even though you may not see ahead of time exactly when or where or how a catastrophe might happen, if you fill a reservoir, you are strictly liable for the consequences of your actions. If you fill a reservoir and it fails, you are, through the act of filling it, responsible. That's the message of the Johnstown Flood of 1889. Upstream from the town of Johnstown, Pennsylvania, an abandoned reservoir and dam had been purchased by speculators. This is an artist's rendition of the original reservoir. The speculators filled the reservoir and converted it into a private hunting and fishing club around a new resort lake. The owners, primarily rich industrialists from Pittsburgh, including Andrew Carnegie, made many mistakes. They didn't price the risk that they were creating appropriately. They made a number of changes to the dam, which created the conditions that led to the disaster. This is what the lake looked like after the changes. In order to make passage between both sides of the lake more convenient, they built a road across the top, wide enough to allow carriages to pass. Doing so, however, required lowering the level of the dam. Even worse, inadvertently, they made the middle of the dam slightly lower than the sides, a tragic mistake. There was a spillway, you can see it on the left side, designed to allow excess water to escape the reservoir safely. But they added a screen of bars in front of the spillway in order to keep the fish in the lake. During the event, this screen got clogged, significantly reducing its ability to drain excess water. Worst of all, before filling the reservoir, they plugged up, rather than to fix, a drain at the bottom of the dam that had fallen into disrepair. Because of this foolish decision, they had no way to empty the reservoir, either to make repairs or to control the level of the lake. In the years after the club opened, the dam frequently sprang leaks and was patched mostly with mud and straw. Expert engineers warned of the danger, but they were ignored. In the week before the flood, it rained almost constantly, and the level of the lake rose dangerously. During the night of May 30th, 1889, the rain intensified, and the lake continued to rise at a rate of 2 inches per hour. The operators tried to protect the dam with sandbags, and they tried to clear the debris which clogged the spillway, but by midday on May 31st, they realized that their defensive measures were hopeless. Shortly after noon, they telegraphed the town of Johnstown and warned it to, quote, prepare for the worst. Over the years, there were numerous false alarms about the South Fork Dam not holding against flooding. The dire warnings of imminent disaster on May 31st went unheeded until it was too late. The water began spilling over the center of the earthen structure a few hours later. This is an artist's rendition of the event. The dam disintegrated. Shortly after 3 o'clock in the afternoon, the catastrophic failure of the neglected dam unleashed 20 million tons of water, which in a matter of minutes cascaded 4 miles down a narrow gorge and in an instant devastated Johnstown, killing 2,209 people. This is a view of the reservoir after the flood. Notice the indication of where the level of the dam had been. This is a view of the aftermath. And here's a view of downtown Johnstown after the event. Now, many mistakes caused the Johnstown Reservoir to overflow. The day of the flood, the catastrophic risk created by the combination of errors turned a heavy rainstorm into a disastrous nightmare. After the flood, the victims brought suit, accusing the South Fork Fishing and Hunting Club of making modifications and failing to maintain the dam properly, such that it was unable to contain the additional water of an unusually heavy rainfall. Incredibly, however, the courts threw out the lawsuit, ruling the dam break was an act of God. The survivors were never compensated. The public was outraged with this ruling, and courts in many states began recognizing the existence of strict liability, the legal concept that certain actions are inherently dangerous. Even though you don't know exactly when or where or how something could go wrong, you're not absolved of liability. Simply put, there was reason to believe that there was risk in the act of filling up the reservoir in an area prone to flooding where there were people living downstream. The Earth's atmosphere is also a reservoir. Today, we are wastefully filling this reservoir with greenhouse gases such as carbon dioxide. These actions are inherently dangerous. We don't know the capacity of the atmosphere to safely absorb emissions. We don't know where the tipping point is. We don't know what disasters might await us. Just as in 1889, the urgent warnings of danger from experts are going unheeded. To manage this risk, we must stop wastefully filling this reservoir. The unknown remaining capacity of the atmosphere to safely absorb emissions is a scarce resource. We must begin using this finite resource more efficiently. We must begin recognizing its value. That's my message. That means allocating carbon emissions intentionally over the course of time by pricing them appropriately. So what is the right price of climate risk today? How much should we spend today to avoid the worst potential outcomes, the unimaginable disasters of tomorrow? How should we think about pricing climate risk appropriately? Think about dynamic optimization in the presence of uncertainty, tipping points, and nonlinear responses. If that's unfamiliar territory, then think about riding a bicycle. The details of economic models to price climate risk and the calculations required are daunting, but humans nonetheless actually have a very well-developed intuition about such problems. We can recognize and understand and solve these problems in our heads in a fraction of a second. Think about a bicyclist racing down a mountain road. I do this quite often, and it is dangerous. I've seen many bad accidents when cyclists I've been riding with have lost control. Some of them are sitting here today. From the time danger is seen until a rider reacts is just a fraction of a second. In that moment, the rider grabs the brakes as he or she formulates a plan to attempt to avoid a disastrous crash. While a cyclist recognizing danger doesn't slowly apply the brake, nor does he grab the brakes as hard as he can. There is an optimal amount to brake as you attempt to maintain your balance while avoiding a crash down the road. Climate risk poses the same kind of problem to solve. What is the optimal amount to brake in the context of uncertainty and potential tipping points with nonlinear responses? Unlike a bicycle, however, the Earth's natural systems have tremendous inertia. What we are witnessing today is a potential disaster unfolding in slow motion. We currently are sitting in a long, drawn-out split second after we have recognized the danger but before we have started to brake. Any additional delay could be the difference between success and failure. Like braking on a bicycle, choosing an appropriate price for emissions is a complex question that should be answered in the context of a fully developed dynamic plan that looks into the future and takes uncertainty and potential catastrophic outcomes into account. The amount to brake for a cyclist depends on the amount of risk, and it depends critically on the rider's attitude toward risk, their degree of risk aversion. In the case of climate risk, the answer also depends on the amount of risk, and it also depends critically on societal risk aversion. It turns out that our main historical experience with societal risk aversion is in the equity markets, and there we observe that societal risk aversion is very high, in fact, puzzlingly high. The most important consideration in pricing climate risk is to recognize that there are fundamentally two different types of risk: diversifiable risk, which can be insured, and non-diversifiable risks, those which cannot be eliminated in the aggregate through hedging or insurance. Diversifiable risks, for example, those covered by homeowners insurance, should be priced at a level given by the actuarially fair discounted present value of expected future damages. Their price depends only on the mean of the distribution of outcomes. But non-diversifiable risks, because they cannot be eliminated in the aggregate, deserve a higher price than the discounted present value of expected future damages. They require an additional risk premium. The best known non-diversifiable risk is equity risk. In the most well-known equilibrium pricing model in finance, the capital asset pricing model, or CAPM, the return of the market portfolio is the only non-diversifiable risk. In this model, all other risks are priced according to their covariance with market returns, a familiar measure for finance professionals called beta. But in reality, there are other non-diversifiable risks. These include, for example, nuclear war, global pandemics, as we just witnessed, mortgage default risk, and climate risk. The magnitude of the risk premium for non-diversifiable risk is a reflection of societal risk aversion and impact most easily measured in the historical returns of equities. This is one of my favorite graphs from finance. On a log scale, it shows the cumulative returns from U.S. equities versus those from U.S. 10-year bonds, both adjusted for inflation, over the past 140 years. The average real return on a 10-year bond was 1.8%. The average real return on the equity market was 6.4%. The degree of mean reversion in these cumulative returns is very interesting. It seems to reflect a time-varying risk premium for equity risk. The recent increase in frequency of those variations and their correlation across markets has been termed risk on, risk off. But that's a story for another day. What I want to focus on is something much simpler and more fundamental: that average degree of risk aversion, which is reflected in the difference in slopes of the two fitted trend lines. This difference represents a steady average return differential of equities above bonds of almost 5% per year. That 5% is the historical equity risk premium. Why it is so large has been an interesting puzzle for economics. We don't have a good answer, but we do know that it is not simply that investors don't like the volatility of equities. Risk aversion is more subtle than that. We know that it has something to do with how much investors value having payoffs which occur in bad states of nature versus in good states of nature, a component of their preference structure which is represented mathematically by the degree of curvature of a societal utility function. Equities typically pay off when times are good. The problem with owning an equity investment is that when you really need the money, when times are bad, such as in the spring of 2009, the investment is likely not to be worth as much as you might have hoped. Consider, as shown here, the returns from a portfolio that is equally volatile, but is long bonds and short equities. Such a portfolio is like an insurance policy. It pays off in bad times. Such payoffs occur in states with high marginal utility, when money is most valuable. As an investor, you're willing to pay a premium to hold such a portfolio. Such a portfolio is expected to lose money, and historically, as illustrated here, it has. Such a portfolio has a negative risk premium. the cash flows from an equity portfolio are discounted at a rate above the risk-free rate, reducing their current price and increasing their expected return. Conversely, the cash flows from a portfolio that pays off in bad times are discounted at a rate below the risk-free rate. The vast historical difference in the returns of these two types of portfolios, which each have equal volatility, reflects the very high degree of societal risk aversion. Now, what does the equity risk premium have to do with price and climate risk? It's a very simple and intuitive connection. The greater is societal risk aversion, the higher is the appropriate price for carbon emissions. As we discussed earlier, the appropriate price of emissions reflects the impact that emissions have on the distribution of damages, both the mean and the lower tail. Uncertain economic impacts depend on future temperatures, which themselves are very uncertain. Physical scientists can give us an estimate of the distribution of temperatures over time associated with a particular path of emissions, such as is shown here. But what they can't give us is any precise estimate of the capacity of the Earth's atmosphere to safely absorb emissions. It's hard, but not impossible, for scientists to create best guesses as to the damages associated with different levels of greenhouse gases in the atmosphere. It's much more difficult to model the tail, that is, to assign probabilities of catastrophes as a function of the level of greenhouse gases in the atmosphere. The level of carbon dioxide in the atmosphere is the climate equivalent of the level of water in the Johnstown Reservoir. What we don't know and never will know with any precision is at what point does the reservoir overflow. That uncertainty is the risk that we must price today. Now, this graph illustrates results that have been commonly built into economic models of emissions prices called integrated assessment models. These include the model used by Lord Nicholas Stern, who wrote a widely publicized study for the UK government. These models were also the basis for the US government estimate of about $20 per ton. The height of the curve shows the appropriate price of emissions in the model as a function of the degree of curvature of the utility function shown on the horizontal axis. Curves like these puzzled me when I saw them for the first time a few years ago. They show that the appropriate price of emissions goes down as risk aversion increases toward the left in this graph. Climate damages are expected to occur mostly so far into the future that it turns out that the appropriate price of emissions is very sensitive to how you discount those future damages. Increasing the curvature of the utility function embedded in these models has two effects. First, it increases risk aversion, raising the risk premium. But when economic growth is assumed to be positive, which it always is, then increased curvature of the utility function also increases the real risk-free interest rate, which in these models decreases the present value of future damages. In the standard models that economists have used, this interest rate effect dominates. Climate scientists have consistently used a degree of curvature which fits very low interest rates, but which also implies a very low degree of societal risk aversion. The problem when you do make that choice is that the models don't actually take risk aversion into account. There's essentially no risk premium built into the price. The climate risk question is not the first time this problem with the standard CARA, or constant relative risk aversion utility function, have been seen in economics. Back in the 1980s, economists figured out that you couldn't fit both the low real interest rates and the high equity risk premiums that we see in the financial markets with this standard utility function. At that time, a couple of very smart, mathematically inclined economists, Larry Epstein and Stanley Zinn, created a new, more flexible utility function. As illustrated here, the additional flexibility of Epstein-Zinn utility was designed to allow a lower degree of curvature over time to fit the low real interest rates that we observe in the bond markets, and a higher degree of curvature over states of nature to fit the high levels of societal risk aversion evident in equity markets. In this graph, I again show the appropriate price of emissions as a function of risk aversion. This time we show risk aversion on the horizontal axis with a scale calibrated to show the implied equity risk premium, and we compare the price which comes from using the standard utility function with that which comes from using Epstein-Zinn. I want to recognize, by the way, my colleague Kent Daniel, who's here tonight, who pointed out to me the critical importance of applying this more flexible utility function and showed me how to use it to better address the issue of pricing climate risk appropriately. What I did to create this graph was to take a Summers-Zeckhauser climate model, build in Epstein's in utility, and look at what happens when we relax the constraint built into the standard utility function. With the standard CRRA utility function, as risk aversion increases, the risk-free rate also increases. The damages far into the future are more highly discounted, and as shown in the red curve, the appropriate price of emissions quickly declines to zero. With the additional flexibility of Epstein's in utility, the real, that is inflation-adjusted interest rate can be held constant at a reasonable level, in this case at 2% per year, while risk aversion is increased to levels that can fit observed risk premium levels in the equity market. The result is the blue curve, in which the appropriate price of emissions rises with increases in societal risk aversion. Now, when we start thinking not only about the current price of emissions, but also the dynamic plan of expected future emissions prices, which represent the optimal plan which must be part of the current policy, then we can begin to understand why forward markets may be useful to policymakers and why I don't believe carbon emissions will rise as fast as Exxon believes. Exxon believes that emissions prices will rise at a rate of 7.6% per year for the next 15 years. As we've seen, emissions prices should rise at a rate below the risk-free rate of 2% in order to reflect a risk premium. I've drawn here a couple of potential paths for emissions prices that start at the current negative $10 per ton, representing the global subsidies to fossil fuel production and consumption. We don't observe liquid forward markets for emissions prices yet, but I show my best guess as to what prices might represent market expectations and how they are changing through time. For example, a few years ago, after the U.S. Congress rejected the President's attempt to price emissions, the expectations might have looked like the blue curve. Today, given a few more years of clear evidence that the impacts of climate change are real, I suspect expectations are more like the red curve. I also graph the appropriate current and forward prices given low and high degrees of risk aversion. With no risk aversion, the expected price should rise at the real risk-free rate of interest, about 2% per year. But as the degree of risk aversion increases, the increased risk premium raises the current price, lowers the discount rate, and pulls the slope of the forward curve down. At higher levels of risk aversion, the slope of the forward curve actually could become negative, meaning emissions prices are expected to decline over time. The intuition is very straightforward. The appropriate price for emissions today is part of an optimal plan, just as the optimal amount to brake a bicycle in the face of danger down the road is part of an optimal plan. Lower risk aversion implies that you brake less hard today than you expect to in the future because you worry less today about the uncertain potential for an accident down the road. Higher risk aversion implies that you're more concerned today about the potential for bad outcomes. And if you're very risk averse, then you might brake hard enough today that you expect to ease up on the brake over time as the risk is reduced. The expectations in forward prices can actually provide an additional potential source of information about the appropriate price for emissions today beyond the uncertain distribution of climate science and economic models. In the forward market, the prices reflect the equilibrium of aggregate bets that investors and corporations make on the future price of a resource. By creating a liquid forward market in emissions prices, society could gain information about market expectations, which could then inform current policy. Just as the Federal Reserve System Open Market Committee can observe in the prices of bonds a market estimate of future inflation and use this information to help inform policy about the appropriate setting of interest rates, so too could a forward emissions price provide society with useful information about market expectations of climate risk. For example, a forward curve that sloped up at or above the risk-free rate would reflect a current price that was too low relative to future price expectations. A global institution designed to set emissions prices today would certainly want to have that information about market expectations of future emissions prices. And in designing a global emissions pricing mechanism, we should be careful to try to encourage that very useful information to be reflected in a liquid forward market. The emissions pricing authority observing such an upward sloping forward curve would have a clear signal that they should raise the current price of emissions to the point where the forward curve is more flat or even slopes down. The appropriate price for emissions today should be high enough that we should expect the emissions price to come down over time or at least not to increase significantly. That's a very useful intuition. Such a forward curve would reflect an appropriately risk-averse policy. Action on pricing carbon emissions is extremely urgent. There are two costs of delay. First, society is wastefully filling up the Earth's atmosphere. Because we are wasting a scarce resource, we are unnecessarily pushing increased costs onto future generations, just as past inaction has pushed unnecessary costs onto us. As illustrated here, when emissions are not priced, the appropriate price going forward rises exponentially over time rather than coming down over time. Had society priced emissions appropriately 20 years ago, then the appropriate price today might be very low and the problem very small. The level of carbon dioxide in the atmosphere would be much lower and the rate of increase much slower. As it is, the appropriate price is high today and growing exponentially higher over time as the problem grows larger. But this future cost is not the main reason for urgency. The main cost of delay is that we may hit a tipping point and lose control. We may crash. The main cost of delay is that we are still accelerating, thereby increasing the unknown probability of a disaster down the road. Although it's a much less significant concern, there's another misperception that I'd like to stress about emissions prices. Many politicians, business leaders, and even some economists have argued that businesses require stable and predictable future emissions prices in order to make appropriate business investment decisions. This is sometimes used as an argument for smoothing prices and delaying appropriate policy. In any case, this argument is not valid. Emissions prices should fluctuate to reflect all information available at every point in time. This slide illustrates the trade-off of optimal climate policy between the cost today and the impact on the lower tail of future events. The horizontal axis shows different degrees of fragility in the Earth's natural environment in the face of the shock that greenhouse gases are creating to our climate. The actual fragility is, of course, unknowable, but the future outcome lies somewhere along this horizontal line. We line up the most fragile scenarios on the left and the most robust ones on the right. It's often said that the world is playing Russian roulette with respect to the future impacts of greenhouse gas emissions. This is indeed perhaps an apt description. We don't know which of these scenarios, all of which are equally likely, will be realized over time. As the future unfolds, we will discover how fragile the Earth's environment is. We'll find out where along this horizontal axis the actual environment is located. The blue policy, business as usual, implies doing nothing to reduce emissions. We compare the damages of this approach in each scenario against two different optimal policies associated with different degrees of risk aversion. The different risk aversion levels lead to carbon emissions prices of around $20 per ton in the less risk-averse case, the red case, and $60 per ton in the more risk-averse green case. Such policies will lower current consumption by around 0.4% in the case of $20 per ton and around 1.4% in the case of $60 per ton. In terms of what all these policies imply for expected consumption in, say, 2090, the middle row in the table, the outcomes are not all that different. Consider the rightmost 80% of this graph, representing the most likely degrees of fragility of the environment. It's perfectly reasonable to assume that the differences in climate policies most likely won't matter for utility in 2090, and to feel confident that there will be time to develop technologies and policies to minimize the degree of damage to future generations. It's reasonable to expect that people in the future will most likely be much healthier, wealthier, and greener than we, and that they have a higher utility than we have today. That's perfectly rational, and it's a positive expectation. And yet, it is also reasonable to worry about what happens in those states of nature where the Earth's environment is especially fragile. What happens if we do get a bad draw at the left edge of this horizontal axis? In those unlucky cases, the differences in these policies matters a lot. And if it turns out that the environment is surprisingly fragile, then business as usual could lead to an unimaginable disaster. This graph illustrates why climate policy is an urgent risk management problem and why failure to price emissions appropriately is an unforgivable risk management mistake. It is rational to carefully consider what is the appropriate degree of risk aversion to use in setting the price of carbon emissions. There could no doubt be legitimate debates about which price in a range of, say, $20 per ton to $60 per ton creates the appropriate trade-off between consumption today and the risk of future catastrophe. What is not reasonable is to do nothing. The current global behavior, that is the blue curve labeled business as usual, does not represent rational behavior. Climate risk should be priced immediately at an appropriate level. And I'm happy to report that economists are beginning to speak out on this topic. On March 14th of this year, 26 leading economists, including 6 Nobel Prize winners, wrote to President Obama urging support for pricing of emissions in the aviation sector, a current global focus. I'll read you a few key sentences from that letter. Dear President Obama, because emissions are not priced, the world is wastefully using up a scarce resource, the Earth's ability to safely absorb greenhouse gas emissions. We are also failing to make appropriate investments in capital that would reduce future greenhouse gas emissions. Our selfish inaction pushes increased costs onto future generations and dangerously increases the probability of extreme events with major impacts on their welfare. These are strong words coming from Nobel laureates such as Ken Arrow, Bill Sharp, Eric Maskin, Tom Sargent, Chris Sims, and Joe Stiglitz. The World Wildlife Fund, on whose board I sit, delivered this letter to President Obama. Sadly, we've had no response from the administration. Although the U.S. administration has not responded to the Economist letter, we are particularly hopeful that global progress will be made soon in aviation, a global industry in which emissions pricing has been initiated in Europe. We heard a message of support from one airline executive, Sir Richard Branson, being interviewed publicly at a U.S. State Department conference in Washington, D.C. on April 26, 2012, strongly supported a tax on carbon emissions in the aviation sector. The EU proposal to price emissions in aviation has caused the rest of the world to confront the issue. We are convening a group of aviation and government officials to discuss the use of market-based mechanisms to push forward pricing of emissions in aviation. We hope to give rational behavior a push forward. Although aviation per se is a small part of the overall problem today, we are optimistically hoping that it could set an example for the rest of the global economy. Two components of that process clearly require further input from academia, and I hope that MIT will rise to the challenge, and I'm confident it will. First, we need better pricing models for climate risk. We need models which take risk aversion into account in calculating the appropriate current and future prices for greenhouse gas emissions. Second, we need global governance structures that ensure that the pricing process is based on science and economics and not on politics or special interests. Let me conclude by asking a favor. When you think about climate risk, please remember the story of the Johnstown Flood. It's a story about incorrect incentives, urgent danger, and strict liability. The Earth's atmosphere is a reservoir with an unknown but limited capacity to safely absorb greenhouse gas emissions. Certain actions, such as filling that reservoir, are inherently dangerous. Failure to have seen exactly what might go wrong is no excuse. It is clear that emissions will be priced soon, but in the meantime, government's failure to price the increased risk created by carbon emissions is an urgent risk management mistake for which elected officials should be held strictly liable. Carbon emissions should be priced immediately, appropriately, globally, and it's time to slam on the brake. Please tell your friends about the Johnstown Flood. Thank you. I think we have time for questions. Is that right?
Maybe one question.
One question. I was hoping to limit questions.
Hey. I definitely agree with you. It's something we need to address, but given the state of the global economy now, is this something we can actually do in the near term?
Well, you know, it's kind of interesting. When you price emissions, that's a source of revenues to governments. And so right now, as part of the fiscal cliff negotiations in the U.S., there's actually not a lot of public talk, but behind the scenes, a lot of negotiating about whether pricing emissions should be part of that revenue compromise. So, yeah, I'm hopeful. And, you know, the state of the economy today, which is kind of a cyclical issue of short-run importance and has political implications, no doubt, but it really doesn't impact the appropriate price for emissions. So if you're asking a political question about can it be done, you know, that's an issue. People's concern about climate risk has gone down in terms of concerns. But one of the problems, one of the big issues with climate risk is that most people don't have a long enough horizon. They don't worry about future generations. Future generations really are not represented very well in society's utility function. So can it be done? Well, I think so. But recognize the other issue is there's a free rider problem. It's not in any one person's interest or one country's interest to move first. So how do you coordinate globally all of the countries around the world? And that's why we're focusing on aviation. It's kind of an obvious global sector where it's clear there should be one global price. And, you know, hopefully we can get that done. I guess that was, is it?
You mentioned Charles Corrigan and Paul Volcker, and Paul Volcker has become, I'd say, a very harsh critic of financial engineering and financial innovation. You know, and I think the statement he keeps making is that no one can point to any benefit to the economy from financial engineering. So I wonder, given your practical experience, are you completely confident that if we had a liquid swaps market, derivatives market, futures market in these products, that it would help the problem, or don't we know?
In these products, meaning forward emissions prices or something. So, well, I think it would reveal information, as I said, that I think would be very useful. Now, can it be, would there be a market for pricing emissions 20, 30, 40 years into the future? Not so clear. So that's a practical question about who would be hedging in that market. But I think it would be very useful to see what those prices are. And so as we think about developing a pricing mechanism, I think it's important to, for that reason, and also because the price should move over time. If we set a tax and we say, all right, here's the tax, can you imagine then trying to change that tax? That becomes very sticky. So I think what would be very helpful would be to have a liquid market, let's say in emissions permits, one where a global institution goes in and buys and sells permits in order to adjust the price appropriately over time. That's really what I'm trying to say. Okay, if there's no other questions, I guess we're dismissed.